Good morning, everyone. Good morning. An exciting day to get things going here. It's going to be a good day, let me tell you that much. I'm pretty excited to talk about the topic today. It's an interesting one. It's one of my favorite use cases for augmented reality. I think it's meaningful and valuable. So if it's your first time here, I appreciate you coming in. I look forward to you chatting with me and staying with me. If you're interested in learning a little bit more about spatial computing and a little bit more about how digital twins are going to be affecting the world, hang around. I promise it's going to be a great talk. It's only going to be about 15-20 minutes or so. This is the Synth Reality Tech Talk. My job is to educate you so you understand a little bit more about emerging technologies and feel a little bit more comfortable about what's going on. Today's topic is going to be about augmented reality and command and control experiences, which are super cool. If you're struggling with the stream, I understand. It happens. It's okay. If you're on one of the other platforms, just feel free to shout it out if it starts getting bad. But also, I'll always throw the Twitch stream in there so you can check it out. That being said, for introductions, I'm Rob Petrosino, futurist, technologist, all around great guy. And my goal is to make you feel more comfortable with emerging technologies, make you feel educated and interested in what's going on, and enable you so that you can go out and advocate for emerging technology in your own life or within the organizations you work for. So I appreciate you coming in. I appreciate you sitting down and listening to me. If you listen to this on demand, if you're listening on a VOD, video on demand, I appreciate you taking some time and checking us out. But with that, we're going to get over to the screen share. So we're going to talk about the spatial computing spectrum. We're going to talk about two pieces of technology that support that spectrum. There's a lot of different pieces of tech that actually support it, but we're going to talk about two specifically today: digital twins and machine learning, and how that affects command and control experiences. If you've never heard of a command and control experience before, that's okay. We're going to talk about them in great detail today so that you feel comfortable. But it's a very traditional way of thinking of how an organization handles situations and how they can visualize all the data that's necessary and required when a event is happening. It's very traditionally used in the military. You may have heard of the term NOC before, NOC, Network Operating Center. It extends well beyond that. And I look forward to kind of discussing it. But let's dig into the spatial computing spectrum real quick. On the spectrum, you have two different ends. You have this physical world on one side and the digital world on the other. If you're interested in overlaying digital content in the real world around you, that is augmented reality. Think Pokemon Go, think about a Snapchat filter, etc. That's on this side. If you're interested in living in a virtual world, in a metaverse for some, right, you are looking more on the digital world or fully encompassed virtual world, right? This is a spectrum. Different experiences can blend or move between the spectrum, but two pieces of technology that support this, especially for command and control experiences, are digital twins and AI and machine learning. Digital twins is something we're going to dig into a little bit here, so we can talk about that. We're going to briefly talk about machine learning, but we're not going to dig into it too much because there's so many different types, from analytical AI to categorizing machine learning to generative AI. There's a lot to unpack there, and we'll talk about it later on, but just know that it is supporting the spectrum. So with that, what is a digital twin? A digital twin is an accurate 3D representation of a real-world object or location. Now, digital twins have a variance, right? They can be incredibly detailed, or they can be incredibly light in the amount of information they have. A very standard digital twin, if you've ever gone on Amazon and you clicked on view this object in augmented reality, that's okay. That is a digital twin, right? I dropped a chair in my space, or I'm looking at a suitcase in my space. That is a digital twin of that product, okay? There is full-scale digital twins of cities, of airports, of warehouses filled with IoT systems, from IoT on the HVAC to water to the pressures of specific manufacturing part. All of these are digital twins as well. So that's the interesting part, is that digital twins range and have a spectrum of maturation or maturity. So what does that maturity scale look like? How does that technically affect those that are dealing with digital twins? Well, that's where we go into this digital twin maturity model. So that first experience, what's going on, Kevin? That first experience is really focusing on a virtual twin or a level 1 digital twin. Jenin, appreciate the tag on LinkedIn. If you have any comments, if you have any thoughts, feel free to hop in here. A level 1 digital twin is called a virtual twin. What a virtual twin does is it allows you to physically and accurately depict a real world object in a digital way. That digital way can be very straightforward. It has to know where it sits in space, if it's interactable, it engages in experience, and is collaborative. Okay, the collaboration aspect allows us to have multiple people experience it at the same time, or have multiple people have access to it, even though there may be a degree of latency, i.e. a one-to-one experience versus a one-to-many. One-to-one being, I only can see this at a single time. One-to-many is multiple people can see it as a single time. That is what we're thinking about in the virtual twin level 1. Okay, that is dropping a chair in the space around us and making sure that we have that. Appreciate the follow there, Caden. Appreciate you following us on Twitch. If you haven't followed us on Twitch, feel free to follow us, but really, really great content and information always coming out through the Tech Talks. So virtual twin is level 1. It is spatially aware, is dimensionally accurate is what I like to say. Okay, a level 2 connected twin allows for real-time data monitoring and reporting, and is typically done through IoT sensors. Okay, IoT sensors are Internet of Things. Those are typically found on everything from HVAC systems to machinery to water pumps, etc. That IoT information is then pushed into that cloud. It is then going through a monitoring or reporting system and allowing that real-time data to be visualized in a connected twin. That is level 2. That means in level 1, we can understand what the size, dimension, and accuracy of a warehouse is. Level 2 means I've taken my IoT data and now can stream that IoT data into the cloud and visualize it on top of that warehouse. If I have that information, then I can move to level 3, which is a predictive twin. Level 3 allows you to do decision making. It has analytics and predictive maintenance. So not only do I know what IoT sensors are saying, but now my machine learning and artificial intelligence is powering decision assistance. Hey, Rob, your Coke manufacturing plant or your soda manufacturing plant in New Jersey that you are overseeing and looking at a digital twin needs maintenance, because previously when you have this many bottles running through the facility, you need to do maintenance. And that's decision assistance. So that's level 3. Now we're talking about something that is truly moving towards a command and control experience, right? I can command and control what maintenance needs to happen. Now, on a prescriptive twin or a level 4 experience, now I can do some what if scenarios. What if something broke? What if I didn't have a team there? What if I pushed the machine to go past recommended maintenance at 100,000 bottles and it moves into 200,000 bottles? What happens there? And now I'm adding on a layer of machine learning to do those predictions in the future, but also create intelligent recommendations and process optimization. Hey, you should actually repair these 3 things at the same time, and this is the order that they should go, so you decrease the number of bottles that are not produced on time. Those are the things that we're going to start looking at in a prescriptive twin. in the level 5 autonomous twin, this is all done for you. The actions and decisions are made for you. There is a full artificial intelligence system that is understanding the data coming in, creating what if scenarios, reading those what if scenarios with synthetic data. We'll talk about synthetic data in a second, and then making actions on its own recommendation. Synthetic data is the fake predictions or fake input of information from an outside resource or from an internal system. Hey, we know we're getting this number of issues related to bottle manufacturing. We have synthetic data set of if we pushed a machine from 100 to 200,000 bottles being produced to 500,000 bottles, what's most likely to fail? That's all synthetically done. So that is a level 1 virtual twin, just that standard one-to-one relationship with a object, and our level 5 autonomous twin that's making all the decisions for us directly. Now, when we move into a command and control experience, the ability for me to come on, review information, see that real-time data, visualize it in an actionable format, and define a situation and control it is a command and control. So traditionally, these are done via NOC, so a network operating center, specifically for the military. That's the military use case, is when I am going and looking at situational awareness, situation that's happening on the ground, and seeing all the information relayed to me. In the context of an AR technology experience is what you're seeing on the right-hand side here. I can go interact with the real world around me, overlay this command center in the way, format, and size that I want, see all the detailed information related to the city, but then also interact with these through gestures, voice commands, and any clicks that I want, so I am in control and I can make decisions faster and more efficiently. That's really what we're aligning to here, is fast and efficient decision making. Instead of having 50 or 30 different screens in front of me, I can now visualize that information in a much faster format, more accurately, and drive to a decision more effectively. That's what we want to do. Okay, so now that we understand what a C2 experience is, we move over to what it looks like traditionally. So a very traditional NOC, or network operating center, is on the left-hand side. Let's review this, and then we're going to talk about the right-hand side and what that means. The left-hand side, you see a slew of people on the ground sitting behind their individual command centers, their individual workstations. They're reviewing different information, whether those are news feeds, whether they're live data inputs, and they have access to other additional information that's on the screen in front of them. Those are those large screens of information, and those large screens of information have much more globally aligned info. That globally aligned info is then shared across all users, no matter where they're sitting. Great. So now they're each individually making decisions. People are moving around and communicating effectively, what you would hope in these types of situations. Now, once I have that information aligned, and once I have that information displayed in a meaningful way, I can make decisions much more accurately. However, what you can see is you are physically limited by the number of screens in front of a user. What you're traditionally seeing is anywhere between 2 to 4 screens that are available. What you can do in an augmented reality C2 or command and control experience is you can pull all this information and have shared resources on the ground. You can see these different, this is an airport simulation. I can see the different information from the terminal directly visualized on field. I can have a topographical map that has depth, height, and width of the different buildings, but then I can also pull in individualized information and visualize it in a meaningful way. That's the big jump that you get from building in augmented reality and having the overlay of all of this information directly at your fingertips and unified without being combined or confined to screens. That's the big gist when it comes to command and control experiences and why they're so impactful and a fantastic use case for augmented reality. That being said, we are at the conclusion of our C2 and digital twin talk. This is why it's so important to think through and understand where your data lives, how you can access that data, and then referring to that data in the long run so it's actionable and meaningful for those that you are talking to. That is a little bit about us. That's a little bit about Command and Control and the technology that supports it. I appreciate you guys coming in, chatting with me, hanging out during the tech talk. I look forward to talking to you guys soon. If you have questions, make sure you check out the socials below. Make sure you reach out to me if you have individual questions. Always here to talk. Shoot me a DM on one of the platforms. I'm happy to guide you along your journey. With that, I look forward to chatting with you guys again. And most importantly, I'll see you guys on the other side.